In section 7.3, we talked about adding and subtracting rational expressions with like denominators. In section 7.4, we're going to learn how to add and subtract rational expressions with unlike denominators. So the first thing we need to do in order to be able to add and subtract rational expressions with unlike denominators is find the common denominator. And the way we do that is we start by completely factoring the polynomials in each denominator of the rational expressions. Then we find the least common denominator by multiplying each denominator by the factor or factors that the other denominators have that denominator is missing. So remember, any factor multiplied in the denominator in step 2 must also be multiplied by the corresponding numerator. And if you recall, that's what we call the trick multiplying by a well-chosen 1. So once you have your common denominator, you just add or subtract the numerators and keep the common denominator. And then, of course, you simplify your final answer. So if we have 4 over 7x and 11 over 14x cubed, how do we find the common denominator? Well, first, we break each denominator down into its smallest factors. So 7x factors as 7 times x. That's all it is. 14x cubed, on the other hand, 14 is 2 times 7, and then x cubed is 3 x's. So we have 3 x's multiplied in after that. Now, how do we get the least common denominator from that? Well, we start with our first denominator. So our first denominator was 7x, so we start with 7 times x. Now we go to the second denominator, and let's just cross off what was in the first denominator. So the first denominator had a 7 and an x. So if we cross those out, what's left is 2 times an x times an x. So altogether, that's going to be our least common denominator. Now, if we multiply that all together, we get 7 times 2 is 14, and x times x is an x cubed. So how do we evaluate the sum then of those two expressions? Well, we had 4 times 7x, and if we go back to this part where our least common denominator is fully factored out, you see we have the 7x, but we're missing a 2x squared. So let's multiply that term by 2x squared over 2x squared. Then we're going to add 11 over 14x cubed. And if you notice, since 14x cubed was our least common denominator right here, we do not have to change anything or multiply that expression by anything to get to the least common denominator. So now let's do the multiplication. 4 times 2x squared is 8x squared. And then 7x times 2x squared is 14x cubed. And then we still have the plus 11 over 14x cubed. Now, if you notice, we have the same denominator. So now all we have to do is add the numerators. So we have 8x squared plus 11 all over 14x cubed. And since there's no common factor that we could factor out in the numerator, and this nothing we can factor out in the denominator, then that's our final answer. So let's do it again for 5 over x plus 2 and 3 over x minus 4. So in this case, we have to treat the x plus 2 as a whole factor and the x minus 4 as a whole factor. So x plus 2 factors only into 1 times x plus 2, and of course we can ignore the 1. X minus 4 factors the same way. It's 1 times an x minus 4, and again we can ignore the 1. So our least common denominator, start with the first denominator. It has an x plus 2, and the second denominator has an x minus 4. Notice I cannot say, oh, they both have an x and only write down one x. I have to use the whole thing. Okay, so to make our two expressions here have the same denominator, we have 5 over x plus 2, and we need to multiply that by what's missing between that denominator and our least common denominator. So what's missing is an x minus 4 over an x minus 4. Okay, now we're going to subtract. We have 3 over x minus 4. And what's missing from that denominator is an x plus 2. So I'm going to multiply that expression by x plus 2 over x plus 2. So what that gives us is 5 times a quantity x minus 4 all over x plus 2 x minus 4 minus a 3 times x plus 2 all over x plus 2 times x minus 4. Remember, we can multiply two numbers in any order. 3 times 4 is the same thing as 4 times 3, so we can write x plus 2 times x minus 4 or x minus 4 times x plus 2. It's the same thing. Now we need to distribute in our numerators, so we have 5x minus 20 all over x plus 2 times x minus 4 minus, distributing in the next one, 3x plus 6 all over x plus 2 times x minus 4. Okay, now we have the same denominators, so we can combine the numerators. So we have 5x minus 20 minus 3x plus 6. And remember, we want to put each numerator in parentheses so we do not forget to distribute our negative in the second numerator. So we have 5x minus 20 minus 3x plus 6 all over x plus 2 x minus 4. Now combine like terms in the numerator, we get 2x, oops, sorry, that should be a minus 6 there. See what I mean about distributing? So 2x minus 26 all over x plus 2 times x minus 4. Now, we need to make sure that nothing can cancel between numerators and denominators. So let's see if we can factor a common term out of the a common factor out of 2x minus 26. Well, we can take out a 2, which leaves us with x minus 13 all over x plus 2 times x minus 4. And as you can see, nothing cancels, so that's our final answer.